Keith Schilling, State Geologist, Director of the Iowa Geological Survey. As you drive around, you see waterways across the countryside, and these are a very common conservation feature. Work that we've done elsewhere, starting at the Neil Smith National Wildlife Refuge, we've been looking at the subsurface properties of grass waterways and see that where they are placed on the landscape, they hold tremendous potential for nitrate reduction. These waterways essentially are filling drainage ways or old ancestral gullies with eroded sediment from the uplands containing a lot of organic matter. Their location on the landscape is low on the topography, therefore they're wet. And so these are ideal conditions for nitrate reduction on the landscape. Many of these waterways are tiled, so they'll tile them to keep them dry, allow traffic to access across the waterways. What we're talking about here with this saturated waterway idea is reconnecting the tile drainage that's draining these systems to the locations where we see all these potential nitrate reductions occurring. So these are ideal settings for nitrate reduction equivalent to saturated buffers. We do not have, in this case, we've just constructed our first test practice and the data is slowly rolling in. It looks very effective. What we've seen elsewhere is we've done studies where we've measured concentrations in the upland areas surrounding the waterway, and what we see is a 70 to almost 100% reduction of upland nitrate being reduced in the waterway sediments. In this case, we're trying to manage that system a little bit and say, how can we reconnect the tile drainage to the waterway to achieve even greater mass reduction? But where it's relatively untiled, we do see all the upland water, groundwater flowing into the waterway, and all those concentrations are reduced significantly. This practice is really has tremendous opportunity to scale. Just about everybody has a grass waterway on their land. Anywhere there's a slope coming together to convey water downstream. So just about everybody has one, and this is a tremendous opportunity to capitalize on that, where the system that we're designing here, it's expanded because we're testing the efficiency here at Clark Porter's farm, but as a practice going forward, it's going to be relatively simple to install. Probably simpler than other equivalent practices. So I feel like there's a tremendous potential to capitalize on these existing grass waterways for serious nitrate reduction. Yeah, this study is a partnership with Clark Porter, the landowner, and staff at Iowa State University and the University of Iowa. So this is a true collaboration across the state's region's universities. This work is funded by the Iowa Nutrient Research Center.
Hi, my name is Jen Merriman. I am a master's student at Iowa State University working on saturated grass waterways. My role in this project is I am really the person that collects most of the data in the field. I come out every week, typically once a week, sometimes more if there's more precipitation in the area. And I grab groundwater samples from the monitoring wells that you can see behind me. And I also take water samples from the incoming tile so that we can take those samples back to the lab and analyze them to see what level nitrate we have in them. And so we can see the reduction process that's happening as the water flows through the grass waterway. I also like to take samples of the depth of the water within the wells and in the control boxes so that we can see how the water is flowing through the system as well, and see the response time to precipitation events. So during my undergrad, I worked as a research assistant, as an undergrad research assistant in the same Streams and Buffers lab with Dr. Tom Eisenhart, and I had the opportunity to really get involved in a lot of different water quality projects. And when this opportunity was presented to me to come out and help research this novel idea of taking a saturated buffer concept and moving it into a grass waterway, I was really excited because this will really open up the door to a lot of potential nutrient reduction happening in the state.
Hey, my name is Matthew Streeter. I'm a soil scientist at the University of Iowa, Iowa Geological Survey. I have been working with Keith Schilling for about 10 years now on water quality projects to improve water quality around the state. Usually these are edge of field practices. Because I'm a soil scientist, I like working with soil health. We like to use the soil to improve the water. And here we are in Rhinebeck. We're at Clark Porter's farm, and we have another opportunity to get even closer to the field with what we're calling a saturated grassed waterway. And so a lot of people are familiar with saturated buffers, and those go along riparian zones. They're put in level along creeks. This is very similar to a saturated buffer in a lot of respects, except what we're doing now is moving up a grassed waterway. So we're actually increasing in elevation, and we're allowed to get into a lot of these high organic matter systems that are otherwise inaccessible for saturated buffers. So as far as the NRCS is concerned, typically you're not allowed to put saturated buffers anywhere that's not flat. We want to be able to use the organic matter. The saturated waterways in this case are chock full of organic matter. We've probably got 5% organic matter at depth here. Now, one of the things that we're worried about with farmers and moving into grassed waterways that are in fields is still being able to drive through those waterways. So what we've done here, and kind of different from a saturated buffer, is we're keeping the water lower. So we have water tables that generally rise almost to the ground surface for a saturated buffer. The water tables here need to stay within maybe a foot to even 2 feet below ground surface so that farmers can still move through them. And so what we have here is a very unique design for a saturated grass waterway, and we're using water gate structures through AgriDrain. Here we are standing at the lower control structure. So in a real world application, if we were going to install this at a farmer's property, this would be the only control structure that would be above ground. Everything else in the practice is going to be below ground. And that's what's so great about the saturated grassed waterway, is the farmer can still move through the field. So everything else is all about the science. Even everything above this structure, these solar panels and these control boxes, it's all really about the science. So we have a rain gauge on top. We're collecting flow data with a control box here. This lower control box is giving us live nitrate data. And so that's what all of these sensors are doing. And I'm going to pop open this box here. And we have a couple of cables. We have a live flow that's being recorded with a radar sensor, and we can maybe get a picture of that, I'm not sure. And in the very bottom of the practice, we have a Nitrotac sensor that's giving us live nitrate readings. Now, this control structure, what it's doing is it's giving us our initial water table rise. So let's say that we want to saturate our grassed waterway 2 feet above the perforated tile. So in this case, we have a perforated tile running right down the middle of the grassed waterway. We want to take care of that organic matter. We want to saturate the organic matter that's maybe 2 to 4 feet below ground surface. And so we're going to put, for example, a 2-foot gate in this structure. That's going to give us a 2-foot water table elevation rise. We saturate the buried organic matter in the waterway. But as we move upslope, you can imagine that the water is going to stay level, but the ground surface goes up. So if the water stays level and the ground surface stays up, we kind of have a law of diminishing returns. So as we move up on the landscape, this 2 foot of saturation is going to be diminished and gone. So we have 2 foot of elevation rise here at the structure, but then as we move up 1 foot of elevation rise, we placed a water gate. So where the water gate's at, which is about 100 feet away, we had a foot of elevation rise, which means we're only saturated about 1 foot now. We've lost 50% of our saturation. The water gate gives us another foot back. So we get all back to our 2 foot of saturation where that water gate's at. And then we continue to do that and stair step up the waterway until we got our 5 feet of elevation rise at the top of the practice. I am definitely applied scientist. I have a farming background. I grew up on a farm, and I like things that farmers like. I realize that a lot of farmers don't want to have to farm through things. They don't want to have to farm around things. And saturating a waterway to the surface defeats the purpose of the waterway. For one, we need to be able to move water off the top of the field. We also can't have water saturating at the surface because we're going to cause gully erosion and things like that in our waterways. It can't happen. What we have in Iowa are these unique waterway systems that are full of organic matter. So we've had erosion that's happened, they're naturally wet spots, and we have a lot of organic matter. Now, because we're in Iowa and we have farming and erosion, a lot of the organic matter that used to be at the ground surface is now buried. So we have post-settlement alluvium or post-settlement eroded materials that are sitting on top of high organic matter in these waterways. So we have to have organic matter, of course, to denitrify, but if it's at depth, we might not actually need to saturate all the way to the ground surface. We don't have to saturate to the ground surface because the organic matter is at depth. So I said, what if we just saturate part of the soil profile, not to the ground surface, but just part of it? And so I was working with Charlie Schaefer at AgriDrain, and we were talking about some different options, and he told me about these drainage control gate structures. They called them water gates. And we were talking about how we can get a foot of elevation rise with those. And in doing so, we have a grass waterway system where we have the elevation rise, but we don't have anything at the top, and we're not saturating all the way to the ground surface. So far, we are seeing, coming out of the drought, we weren't exactly sure how water would be moving through, but so far we're seeing that the practice has been completely full for about 3 months now. So water started moving through the practice in January, really in mid-February. To late February, the practice completely filled up with water, and we are now moving water out of the overflow at the top, and we're bypassing the practice. So we've taken somewhere around, and this is kind of a guess, but somewhere around maybe 80% of the water has actually been contained in the practice, and the rest has been overflowed. So we're taking a huge amount of the water. As far as the water quality information is concerned, we haven't analyzed a lot of that data yet. We have samples that are being collected from all of these wells, and so that's still pretty preliminary. Once it stops raining, things slow down, probably in June, we're going to start looking at that data a lot more.
My name is Clark Porter, and I'm the manager for Porter Family Farms, for our family farm. And the reason that we've participated in this project is because it presents a tremendous opportunity. If we can treat nitrates in waterways, as opposed to some of the standard practices that we have right now for edge-of-field treatment of drainage, such as bioreactors or saturated buffers, and saturated buffers in particular. With saturated buffers, we're just confined to stream banks. We have 2 saturated buffer lines on our farm. But as long as we're confined only to stream banks with those, we're going to be limited in the amount of drainage that we can treat. But if we can work with grassed waterways, then we have just exponentially increased available area for natural filtration of the nitrates. I was particularly curious, as you know, being involved with farming and farm production, is the degree to which the waterway would still function as a waterway. We know that we can find out already that it's functioning in terms of handling the water, and that treating the water, handling the water, staging the water table up the waterway, all of that appears to be working according to the measures we have. The next thing, of course, is that we can't compromise its functioning as a grassed waterway, because grassed waterways also provide a lot of ecological benefits, and we can't compromise that. And thus far, it's been interesting. I've been out here after some of the really heavy rains we've had this spring, and this has been this has been a very wet spring. And this waterway has been no wetter than our other waterways, and it's dried out just as fast as the other waterways. So I'm pleased to see that. We've got some improvements that we need to do to the waterways subsequent to the construction and in putting this, this system in place. And there's some improvements I need to do to this waterway anyway. We're always struggling to maintain waterways. That's just, waterways need maintenance. But we're going to be able to do all that and still have this thing function. And I think an important thing to point out to other farmers and farm managers is that the equipment you see here, the instrumentation up the waterways, the standpipes that we're using to measure nitrates, none of that would be there in a normal system. All you'd have is this little box at the bottom, and that would be it. And if all of this works, that's the only thing that any other one like this would have. We're planting today. It's a little late. Once again, been a very wet spring, but everything's going well. We've got the edges of the waterway conducive to planting here. Even though we've got, even though we're stair-stepping the subterranean pools of water up the waterway a little ways, that is staying within the waterway. I was driving through the waterway last night with a compact utility tractor. It was same, the ground conditions were the same as I've encountered elsewhere on the farm. So all of that's, I'm pleased to see all of that working. It's a small price to pay for us, very small, non-existent really, to participate in this research and to try to help out with the nitrate issues and with drainage issues that we have in the state. And I want to, if I may, put a little pressure on everybody out there that when you have an opportunity to treat your nitrates in the water and to treat nutrient pollution in the state, either with practices in your field or edge of field practices, and ideally we need to layer these. Farmers, we need to do this. This is imperative because we're finding more and more difficulties, more and more problems with nitrates. But the nitrate output in Iowa is nothing to brag about, and we all can play a role in it. Whether it's planting cover crops, putting in saturated buffers, reducing your nitrogen inputs, managing those things. This can be done and still stay profitable and still be productive. And so I would really urge everybody to get involved, contact your local soil and water conservation districts, Iowa Department of Agriculture and Land Stewardship, NRCS. There's county offices, there's offices in every county in the state. And talk with people about what you can do on your farm.